Hi, I'm Vincent Fernandez from Cypress Semiconductor, and I welcome you to this demo for the digital panel meter. This is one of our solutions developed by the CSBU, that is the Cypress Solutions Business Unit, in partner with one of our premier design partners, that is Triveni Electronics. We have a board right here, programmed for a range of 0 to 300 volts, and we will see a demo of this. So first we will look at the specifications for this board. You can see on the screen, the auxiliary supply voltage is 230 volt AC plus minus 10%, but the auxiliary supply can be anywhere from 5 volt. You only need a power supply that brings down the voltage to 5 volts for the circuit to work. So an auxiliary supply need not be 230 volts in all applications. The measuring voltage as of now on our board that we are going to demo is from 1 volt to 300 volts, but by changing a couple of resistors we can go to any other voltage range needed. We have a version of this board which will also work for current. So in the case of the current, we can measure from 50 milliamperes to 5 amperes with a resolution of 1 milliampere. The measurement accuracy is 0.3% true RMS, but in lab tests we have seen that the accuracy can be at 0.1% and even better. The operating frequency for the true RMS will go from 45 to 62 Hertz. Again, in lab tests, we have seen it will give the correct true RMS value up to 100 Hertz. The display is a simple 4-digit 7-segment display, and we have 2 keys for calibration and setting parameters. The main applications for the digital panel meter will come in the industrial domain, in industrial panels for industrial automation, and in industrial measurement and control. Why Cypress solution for the digital panel meter? First of all, this solution that we have measures true RMS, voltage and current. It's a single chip solution. It does auto zeroing on power up that saves 1 point for calibration. It operates from a single plus 5 volt DC supply. We do not need any dual supply voltages in the system. It's a very small form factor, very low component count, and it has been tested for EMI and EMC compliance. The advantages that PSOC brings to this solution: we use 11-bit Delta Sigma ADC for very accurate measurement of the voltage and current. We have an onboard programmable gain amplifier that allows us to scale the input depending on the range. We also have an on-chip voltage reference. So this reduces the external component count. We also have some optional features that are currently not included on the board, but that can be incorporated, such as we can have a Modbus interface, we can have 4 to 20 milliampere current retransmission output, and we also can have a PC GUI software for calibration. And depending on the need for each customer, we can customize the voltage and current calibration and measurement ranges. Now we will show you a demo of the performance of the board. We are at a test facility that does calibration and testing, and we have our DPM digital panel meter board connected to a reference source and a reference meter, and we are going to apply a series of inputs to it, and we are going to see what outputs we are getting on the display. The display on the reference meter is going to be very small. Right now, if we see the voltage input on the reference is showing 0.0, and that is exactly what the DPM is showing at this moment. We will now feed in 25% of the input. The full scale for the source is at 220 volts, that is 100%. So 25%, our meter reads 54.9 volts, and on the reference meter we have 54.9 volts, 54.94 to be precise. We will now move to the next point, that is 50%. The DPM reads exactly 110.0, and the reference meter reads 110.04. So we are almost matching the accuracy. We will move to the next point, that is 75%, 165.0. That is what 75% should give us. 50% of 220 volts, that's 110, and we are at 165.0. We go to 100% for the next step. This should read 220 volts. So we have 220.1, and on the reference we have 220.071. 110%. So that is 242.2 on the DPM and 242.0. So far we have seen the test results by varying the voltage at a constant frequency of 50 Hz. Now we will keep the voltage constant at 220 volts, which is 100% of the source, and we will change the frequency in the range that we had specified, that is 45 to 63 Hz. So we can change the frequency to 45 Hz now. The frequency is now 45 Hz. You can see it here on the reference meter, and the reading on the panel meter is still 220.0. We'll now change it to 48 Hz. We'll wait for the frequency to settle. You can see 47 point, and the reading on the meter is still the same. We'll now make it to 54 Hz. So we have 53.999, and the DPM still reads the same voltage. We'll now move to 58 Hz. Our source has settled to 58 Hz, and we are still reading 220. You can see the voltage on the source is now 219.9, for which we are reading, and it is fluctuating between 219.9. Then you go to 62 Hz. We are reading 219.8. The frequency meter shows 61.99, and the voltage reads 219.8. So we have perfectly matching readings throughout the range. So we have seen the demo of the performance of the DPM by changing the voltage, by changing the frequency. So I would like to emphasize that the solution here by Cypress is a programmable solution, a very cost-effective solution to address the needs of the digital panel meter market.